Jai Hind everyone. Myself Suvarna Mujumdar, Assistant Professor in Electronics and Communication Department in Akgec Engineering College, Ghaziabad, welcomes you on the lecture on tabulation method. We are doing this lecture so that we can understand how this method helps us to minimize the Boolean expression, and we can design a logic circuit according to the expression we derived after solving the method. So, tabulation method is also known as Quine-McCarthy method. This method is particularly used to minimize a function where we have a variables more than 6. For variable less than 6 or around 4 or 3, we use a Karnaugh map to solve the expression and to find the minimized expression, Boolean expression, so that we can design a circuit for logic circuit based on that derived expression. But when the number of variables, the input variables are more than 6, in that case we will go with this tabulation method, and for this we can write a computer program also which will help us to reduce the function in a standard form, that is an SOP form. So, the steps which we have to follow for using this tabulation method, in the first and foremost step is we have to first find out the sum of min terms, or we can say we can have if a function is given to us, then in that function we have to first convert it into a sum of min terms form, that is summation form, and from that min terms we have to find note down all the min terms in an ascending order, and we have to make a group. Second step, we have to make a group of that min terms considering number of ones present in that particular min term. For example, if we say 2, so we have to first write the binary representation of 2, that is 0010, and in 2 we find that then the number of ones present is single, so it comes into the second group. Then the third step that we are going to do is we have to make a compare the adjacent group. We from the min terms we make groups. Suppose we have 4 groups, then group number 1 and 2, we compare the 2 adjacent group and we have to combine the and make the pair. And we have to in this case, when we are comparing 2 min terms, we have to find that there will be a single bit change, or we can say there will be one difference only, that if we have 4 variables A, B, C, D, then there must be only a single change in one variable, and we have to mark dash line on that variable. So, these are the steps. We take one example and we will do the calculations according to these steps, and we will learn how this method help us to reduce the expression, to find the reduced expression after minimization. Now we have to repeat the step number 3 till we don't have any further simplification, or we can say grouping will be not there. So there will be stage 1, stage 2 and stage 3. Suppose in stage 2 we don't have any other group that should be common, then in that case we will be stopped there, and then we will have to find the remaining terms that are known as prime implicants. Now these prime implicants we have to construct. In the step 5 we will construct a prime implicant table, and from that prime implicant table we have to find the essential prime implicant. Now which terms we can say that they are the essential prime implicants? Those covering terms that do not by another terms. We will see how we can find this essential prime implicant, and after finding the essential prime implicant we have to write a simplified Boolean expression, and then using this Boolean expression we draw the logic diagram using gates. So let's start with one example. So let us take an example. A function is given to us. So let's take a function with summation m, that is the min terms given to us, that is 6, 7, 8, 9, and Now I am taking an example in which we have a don't care also given to us, that is with the term D. So the don't care which is given to us are 10, 11, 12, 13, 14 and 15. Now in this example, a function is given in terms of min terms, but if a function is given in terms of expression like a plus b or something like that, in that case we have to find these min terms from that expression and we have to proceed from here. Now from this case, as we found that there are 6, 7, 8, 9, these 4 are the min terms and we have a 6 don't care condition. But to solve the expression and find the minimized expression, we have to consider don't care also, like whatever we, when we are pairing it in the Karnaugh map, we consider don't care in the pair of 1. Similarly here also we have to consider don't care as a min term and we have to solve the expression. So we start with column 1. And in this case, or we can say first, initially the first column will be where I have to represent these min terms in term of their binary representation. As we say that the maximum min term is 15, to represent these binary min terms we required only 4 variable. So let's take 4 variable as A, B, C, D, and we will have to find M6, that is 0, 1, 1, 0. Then M7, that is 0, 1, 1, 8, 1, 0, 0, 1, 0, 0, M9, that is 1, 0, 0, 1, M10, 1, 0, 1, 0, M11, 1, 0, 1, 1, M12, 1, it's 1, 1, 0, 0, M13, 1, 1, 0, 1, M14 and M15. Now once we arrange these in their binary representation, now we have to go with the group 1 grouping. So we have to find a group where we consider 0 ones. So here we don't have any min terms with 0, 1. So we go with group 1, that is with the min terms which consist of single 1. So here you can find this 8 is the only number where we will have only a single one. So for the first group, we will have 8, or we can write it as 1, 0. This is A, B, C, D, and this is our min term. So this is group 1. Now in group 2, we have to find those min terms, or we consider those min terms which has 2 ones. So here you can find this as 10 from starting with 6, 10, 9, 12. So these are the min terms where we have 2 ones. So this will be our group 2, 6, 9, 10 and 12. Now group 3, where we will have 3 ones in min term. So it's 7, then we will have 11, then we will have 13 and 14. And we will have 14. Now maximums are covered, only one is left, that is 15, and we consider it in a group 4 where we have all 4 ones. So now we will have a column 1 where we have min terms like this. Now the next step is the we have to compare and we have to make a pair. So in the second stage, stage 2, in stage 2 we have to compare and we have to find a single bit change in between two adjacent min terms and we have to make a pair. So starting with here, we can find that you can, when we go with this pairing, you just have to check the min terms will be in ascent. Like in 8 and 6, the 8 is bigger than 6, so we don't have a pair between 8 and 6. So we have to go with next one. So we have a pair with 8 and 9. I will make a check mark so that we can know that we have covered these two one and we go forward. We make it from stage 1 to we transfer it to stage 2. Now the difference is on the position of D. So the where it is position of D, I make it as dash A, B, C, D. 8 and 9 are covered. Now when you go with 8, you have to check with 10 also, 12 also. 6 is not possible, so we go with 10 and 12. It is the higher one. So you find that difference between 8 and 10 is 2. Then it will be the pair will be made. Whenever the difference is in the form of multiples of 2, there must be a pair formation. So here we will have an 8 and 10. So 1, 0, dash 0. Then in case of 8 and 12 also we will have one pair. Now second step, the pair between group 2 and group 3 minterms. Now from group 2 we start with 6 and in group 3 we find the 7. So 6 is smaller than 7, so there must be a pair and the difference between 6 and 7 is 1, which is 2 raised to power 0, that is 1. So we have a pair between 6 and 7. So we can write it as 6 and 7 and we will find that the difference is at D position. So I make it D. Now after 6 and 7, 6 is compared with 11, not possible. The difference 11 and 6, 5. 6 and 13, the difference will be 7. 6 and 14, the difference will be 8. So there will be a pair between 6 and 14 because the difference is 8, that is 2 raised to power 3. So and you will also find that the position A position, it will have a bit is different, rest of the bits are same, so I mark it dash and rest I mark it as same as 110. Now with 6 we covered all the things. Now so from stage 2 we have to move to stage 3. Now in this case, when we are going for stage 3, we have to again check for the numbers like whether the min terms are greater or smaller. Okay, so we will just now in case of stage 3, we have to make a pair between the first stage and second stage, group first and group 2, and in that where we have 8 and 9 and rest are 6, 7. So that it will not make a pair because the next one should be larger or bigger than the upper one. So we have the first pair is between 8, 9, 10, 11. Okay, then we have a pair between 8, 9, 12, 13. Then we have a pair between 8, 9, 8, 10, 12, 14. Okay, and you will find that 8, 10, the difference is 2, 9, 11, again the difference is 2. So in group 1 and group 2, the difference is 2. Here the difference is 4. Here again the difference is 4. So difference will be 4, means we have now in stage 3 we have 2 dash lines in the 2 position, initial one and the next one. So we have 2 difference position. Then in next we will have a group between 2 second group and third group. In that case we will have 6, 7, 14 and 15. Then we have 9, 11, 13 and 15. So here we have 1, already we have 1 difference, 1, and here we have 2. So here we will have the difference is 1 and now 8. Here the initial difference is of 4 and then we have a initial difference is of 2. Nine and 11 the difference is 2 and now 9 and 13 the difference is 4. So we have 2 comma 4. Then we have 10, 11. The group is 10, 11 and 14, 15. Here we have 1 and 4. And then 12, 13. The difference is 1 and then 14, 15 the difference is 2. Okay. So this is our stage 3. From stage 2 to stage 3. Now in this case we have 2 groups only. In stage 2 we have 3 groups. Now stage 3 we have 2 groups. Now we have to find for stage 4. Now when we are moving from stage 3 to stage 4, in this case we have to check for again group 1 and group 2. Now the first will not be paired with the first one because it's the other one is a larger one. So we have to go with the pair of next one. So you can find that what is the difference here in this case. So 8, 9, 10, 11. 8, 9, 9, 11, 13, 15. So we don't have the group between these two because we need to find the common one. Now in this the next case we will have 8, 9, 10, 11. This one 8, 9, 10, 11 and then we have 12, 13, 14 and 15 because these are the two where we have the common terms 1, 2. Got my point? Here we don't have a pair of this with another any of these 3 because 1, 2 we don't have 1, 2 here, 1, 2, 1, 4. We have 1, 2 only for this case. So we will have now pair between 8, 9, 10, 11 and 12, 13, 14 and 15. Okay. So here the difference will be 1, 2, 4. 8 and 12 the difference will be 4. So now we will have a dash line at the 4th position also. Now we go with 8, 9, 12, 13, 1, 4. We will search for 1, 4. So here it is 1, 4. We will have 1, 4 here also. But when you write, you will find that 8, 9, 10, 11, 12, 13, 14, 15 already covered and the difference will be 1, 4, 1, 2, 4. So already we have written this thing. Now in the third case, here 2, 4. Again we have 2, 4. We will find this. And when we go and write in an ascending order for making a pair, you will find that 8, 9, 10, 11, 12, 13, 14, 15 already covered. So this is why my prime implicant, I can name it as P, and you will find that this number is all remaining here. So we can write it as Q. Rest all the minterms are covered. So we obtained 2 prime implicants from this reduction method or tabulation method, and now we have to prepare a prime implicant chart for this case. Okay. Now prime implicant chart PI we are writing for first case is P. We write it as 8, 9, 10, 11, 12, 13, 14 and 15, and next is Q which is covering 6, 7, 14 and 15. Okay. When we are drawing this prime implicant chart, now the case come into the case that we have only 4 minterms that are common or we can say that are main minterms. Rest are the don't care conditions. So we don't consider in prime implicant chart, we don't consider This is our PI chart. So in this PI chart, here we will write prime implicant and here we will write min terms. So we will consider only the min terms which are given to us, that is 6, 7, 8, 9. We don't consider the don't care terms here in this prime implicant chart. So from here we can find that which prime implicant covering 8 and 9. So the first one is covering 8 and 9 and the second one is covering 6 and 7. Now here, from here we will also have to, first we have to mark these min terms which is covered row wise, that like Q is covering 6 and 7, P is covering 8 and 9. So I mark the cross here. Now column wise we have to check, row wise we have to mark the min terms, column wise we have to check which column is having a single cross. So in this particular example, all the 4 columns have single cross. So we circle it just for the knowledge purpose. We do this for all the 4. Now when we see column wise, min term wise, we have to check which are the single cross is present. So all these 4 are having single cross. Now after this we have to check these circles belongs to which prime implicant. Now in this particular example, all the circles, like 2 circles belongs to Q and 2 circles belongs to P. Now in this particular example, P and Q both are essential prime implicant. Means these 2 prime implicant must be there in our Boolean expression, minimized Boolean expression. So in this case, we will write these 2 as our P as A and Q as BC, and we have to consider these 2 in our Boolean expression, and the final minimized Boolean expression will be A plus BC. So this will be our minimal Boolean expression A plus BC. And to draw a circuit for this, we have initially we have 4 variables A, B, C, D, but in case of final expression we have only the 3 variable A, B, C, and when we find this as a minimized expression, we have to consider only 2 gates. One is AND gate, where we will have B and C as an input, and next we will have one OR gate, that will be A. Okay. So in this way we will draw a Boolean expression, we will draw the final logic diagram considering this as our Boolean minimized Boolean expression. Okay. So recalling the steps, first we have to write the min terms in ascending order. We have to find groups of number of ones, and when we make a group of all these one, just I can do this. Yeah, we have to consider min terms, then we have to make a group of min terms by number of ones. Then we have to make a comparison between each group, and you have to keep this in mind that the comparison must be with the adjacent group only. It's not like we have to shift to from first and third. We have to make comparison between first and second, second and third, third and fourth. But yes, the terms which are present in group number 1 must be compared with group number 2, all the terms. It's not like only single terms you have to compare. You have to compare with each terms. Each min terms has to compare with the other one. And one thing that keep in mind, the group number 1, the min terms present in group number 1 must be smaller than the min term present in the group number next group or subsequent group. Then this you have to repeat this until you go with reach to the final when you don't have any groupism. And now then you have to find the prime implicant and from that prime implicant you have to create a prime implicant table. Now from prime implicant table you only consider the main min terms. You don't have to write don't care conditions, don't care variables in that prime implicant table. And from prime implicant table we have to find the essential prime implicant by seeing from column wise that which column consider only a single cross. Finding the essential prime implicant, now we have to add these essential prime implicants in my minimized expression, and then if rest is not there, we will go with final one. So this is all about this tabulation method. Thank you.